So, what exactly is sharding? At its core, sharding is a method for horizontal scaling. Instead of simply upgrading a single, more powerful server, a process known as vertical scaling, sharding involves intelligently distributing your data across multiple independent database instances, which we call shards. Think of it like taking a single massive library and splitting it into several smaller specialized branch libraries, each managing a specific collection of books. The primary purpose of sharding is to dramatically improve performance, enhance scalability, and ensure higher availability, especially when dealing with extremely large datasets or high transaction volumes. By spreading the database load across many servers, you effectively eliminate the single points of contention and bottlenecks that a monolithic server would inevitably encounter. This approach contrasts sharply with vertical scaling, which eventually hits physical and economic limits. Sharding, however, allows you to scale out almost indefinitely by adding more commodity hardware, making it a highly cost-effective solution for growth. Conceptually, each shard holds a distinct subset of your total data. Together, all these shards form your complete logical database. When a query comes in, the sharding system knows precisely which shard to direct it to, based on the specific data being requested. This intelligent data distribution and routing is absolutely key to its efficiency. At the heart of any sharding strategy is the shard key. This is perhaps the most crucial decision you'll make when implementing sharding, as it fundamentally dictates how your data will be organized. A shard key is essentially a column or a set of columns within your database table that the sharding system uses to determine which specific shard a particular piece of data should reside on. Think of it like a postal code for your data, directing it to its correct address, its specific database shard. Its importance cannot be overstated. The shard key is critical for both efficient data distribution across your entire sharded cluster and for ensuring that incoming queries are routed to the correct shard quickly. Without a well-chosen shard key, the significant benefits of sharding can be severely undermined. What makes a good shard key? Ideally, it should possess high cardinality, meaning it has a wide range of unique values to allow for many potential distribution points. It should also promote even distribution of data across all your shards, preventing any single shard from becoming an overloaded hotspot or bottleneck. And generally, it should be immutable, meaning its value doesn't change once assigned to avoid complex data migration issues. The impact of a poorly chosen shard key can be quite significant. It can lead to severely imbalanced loads where some shards are constantly overwhelmed with requests, while others are underutilized, creating those dreaded hotspots and severely impacting overall system performance and scalability. This is precisely why careful consideration and rigorous testing are absolutely essential when selecting your shard key.